Alright guys, so I know that some of you are not in class today for 4.9 and it's a pretty crucial section. So I made this video so that you guys can watch it, or if you're struggling with 4.9, never a bad idea maybe to come back and watch this video. What 4.9 is all about is putting scale changes and translations all together in equations and graphs and whatnot. So at the top here, I actually have three generic formats, sine, cosine, and tangent, that you'll see. B is a number in front of each of them. A is a number on the inside, on the bottom. K is a number on the outside. And H is being subtracted on the inside. So each one of those tells us something. And what I'm first going to do is show you how the scale change rule and the translation rule would be formed. I'm actually going to save those characteristics for after the rules. I like to build the rules first. So in this rule, whatever number you have on the bottom here, first of all, it's on the inside, so it's horizontal. It's going to go with x. And if you're dividing on the inside in the rule, you multiply by that value. So whatever number's down here, that goes with x in your scale change rule. The number that goes with y is a little bit easier. It's whatever number is on the outside, which for all three of these was b. And so that gets you some sort of horizontal stretch or compression and some sort of vertical stretch or compression. For the translation, you want to look for addition and subtraction. So I'll just put a little addition and subtraction symbols here. And again, on the inside, we're subtracting h. So in the rule, we're adding h. On the outside, we're adding k. In the rule, that stays the same, y plus k. And so things like your vertical translation, that is your k value. Your phase shift is your h value. Period and amplitude, we've already talked about this. Amplitude is going to be the absolute value of this number in front, or this number with y in the rule. And the period, it changes. It's either 2 pi times a, that number, absolute value of a, if we're talking about sine or cosine. For tangent, it's pi times the absolute value of a. And if you want it in degrees, it's simple. Replace the 2 pi with 360. Here's the thing though. In order for this all to work so nicely, to be able to take these things and just drop them in to the places we need them, you got to have the equation in this format. And sometimes it's written in that format, and sometimes it's not. So for example, if you look down here, at first glance, this equation probably seems okay, but it's not. In the past, I've always avoided giving you a horizontal translation with some sort of horizontal stretch or compression, but not anymore. You have to separate this 3 from the rest of the stuff on the inside in order for all of this stuff up here to work. So I'm going to rewrite the equation here. 2 on the outside's fine. The issue really is I've got to factor this 3 away from the theta and the pi in order to make it look like the equation above. So on the inside, I'm going to rewrite this first as 3 and then another set of parentheses, theta plus, and it won't be pi anymore. It'll be pi over 3, which is weird, I know. You're just taking a 3 out of pi, so that would leave you with pi over 3. If you're not sure if you're ever correct, just distribute, and you should get what you started with. If you redistribute the 3, you'll get that. If you really look at it though, it's still not in the form that we're looking for. I'm going to write that form down here. It's really convenient to have this a value on the bottom, and I currently don't have that here. And this is weird, but you're going to think of multiplying by 3 here. That's the same as taking this theta plus pi over 3 and dividing it by 1/3. Because when you divide by 1/3, you'd flip and multiply and you'd get right back to that. So it's weird. It kind of looks like we've made the equation more complicated, and I suppose in a way we have, but now it lines up so nicely with this format. And when things are in this format, it's really easy to then build your rules. So your scale change rule is always ax comma by. Well, a for us is 1/3, so 1/3 x. B is 2, so 2y. If you're like, wait a minute, I don't get this. I see the 1/3, why are we writing it there? Well, here you're dividing by 1/3. So in your rule, you're going to multiply by 1/3. That's how horizontal stuff works. Vertical stuff is nice. We don't have to do that. The translation rule is always x plus h, comma, y plus k. So here our h value is actually already positive. In the generic form, there's a minus sign there. So just think opposite. That's going to be x minus pi over 3. And then there's actually no k value, so no vertical translation that we have to worry about. I'll go ahead and write none here. Your phase shift is left pi over 3. Your amplitude is 2. The period's going to be 2 pi times 1/3, which equals 2 pi over 3. Now, we have all the details. Now what we need to do is actually graph this thing, which I know is a little annoying. It's on the next page. So we're going to take this info. I'm going to rewrite it on the other side so we have it. I'm going to write the rules just at the top here. And we're drawing sine in radians. So it's kind of an extra step. I know a lot of you are at the point where you probably don't have to draw the parent function. That's fine. For our sake, though, I'm going to draw it. And normal parent function for sine, point at 0, 0, pi comma 1, no, I'm sorry, pi over 2 comma 1, pi comma 0, 3 pi over 2, and 2 pi. And connect. So there's our parent function. Now, here's the thing. Always, always scale first. Do the scale change first. So there's kind of like an in-between step happening here. We have to apply the scale change. And then on the next step, we will worry about the translation rule. So, we have to multiply our x's by 1/3. That's really going to compress that graph horizontally, but stretch it vertically with that 2y. So 0, 0 is going to stay. Pi over 2 is now going to be at pi over 6, comma 2. This point right here will now be at pi over 3, comma 0. This point will now be at pi over 2, comma negative 2, and that point will now be at 2 pi over 3. And we connect. I probably shouldn't have done a solid line because we are not done. We now have to take this graph. This is just our in-between graph. We have to take that graph and apply this rule. This translation rule, sorry. Now the good news is I don't have to do anything to the y values. They're going to still go up to 2 and down to negative 2. But I am shifting everything to the left, pi over 3. So this point at 0, 0 is now at negative pi over 3. The point at pi over 6, and this is kind of, annoying, pi over 6 minus pi over 3. You might have to rethink that pi over 3 is a 2 pi over 6. That puts us in negative pi over 6. Pi over 3 minus pi over 3, oh, this is a little crowded. My graph isn't the best spacing here. Let me get a little white out, actually. So, make that negative pi over 6. There we go. So this point, pi over 3, shifts to that point right there. Pi over 3 minus pi over 3 is 0. Then I have to take pi over 2 minus pi over 3. Think of this as a 3 pi over 6 minus a 2 pi over 6 gets you a pi over 6. And we're down at negative 2 on that. And then 2 pi over 3 minus pi over 3 is 1 pi over 3. Alright, and now we have our final graph. And hopefully you can clearly see, oh hey, it has an amplitude of 2. The cycle goes from negative pi over 3 to positive pi over 3. That would make the period 2 pi over 3. So everything we found on the front hopefully makes a lot of sense with what we see on the graph. Now, I'm not going to do the entirety of example 2, but I want to point out that example 2, it's already in the form that we need it to be in. It's in that standard form. Oops, that should be an H. I just wrote the pi in there. It's already in that form. So I'll be able, and you'll be able to, find all this stuff down here really, really quickly. All right, guys, keep practicing. You'll get it.